ahead. Welcome, everybody. Great to see you. Go through a couple of quick updates so we can get to Tim talking about cooling strategies for Passive House. Passive House, Minnesota, we have an in-person happy hour in Northeast Minneapolis, and that happens every other month generally. So make sure you sign up for the newsletter so you can see those announcements. We also post on social media, Instagram and LinkedIn and Facebook as well. September 2nd, Tuesday, 7 to 8:30 p.m. at Bauhaus Brew Labs is our next one. And then we have these presentations on the fourth Tuesday of the month. All right, so last meeting, we actually skipped July. So June, we talked about the state fair, and in a very short period of time, thank you for everybody who came together. We had our meeting where we just brainstormed ideas for this display at the state fair. We had a very small footprint. 18 by 18 is what they gave us, and they basically said we would love to have a display explaining thermal bridging. So like, how do we explain thermal bridging in a very simple manner at the Eco Experience Building at the State Fair, right? So we had some discussions. We met at the happy hour in early July, and we did a quick SketchUp model where this was our concept, and we decided to push them from 1818 to 18 to 24, which they accepted, which was great. And here you can see Colin did a great job building this base and these posts. And then I put the graphics together, and he built this thermal bridge box on the top, and he has these little heating elements that he rigged up. So basically the state fair turns, the Eco Experience people just turn these little heaters on, leave it alone because it has a 12-hour timer. And here's some state fair pictures. Here's me with my friends.
Sam freezing.
Yes, and Sam came when I was volunteering on Saturday, which was
Awesome.
awesome. Yeah, so got a picture of him. But we have the thermal bridge, the bars that Colin was talking about. So we have the heating elements on one end. You can feel that the heat definitely transfers through those bars, and then we have the thermal break. I actually had someone say that that was the first time that they really understood thermal bridging, Colin. So well done putting that together, because it can be hard to simplify these concepts for something like a simple display at the state fair. So I think it's really effective. And then because it's a tactile element, you have people pausing and touching it instead of just more signage to read. So I think that's really great. And then we have this triple pane window down below as well that we got donated. So stop by and see that at the state fair. So thank you, everybody.
Don't forget Tim's dirty air filter.
Oh yeah, sorry. No, I definitely
Super.
point these out too. Yeah, they're really gross. So you got to check those out in person. So this turned out well. We have Vanna tape holding it up there.
I just want to make sure people understand that's filtered outside air. That's not the
Yes,
inside air.
I need to put in an additional label because I realized people are so used to seeing the filter out of their furnace that they're not quite understanding that that's all outside air. So I
Yeah.
did say that to quite a few people, and they're just like, "Oh God, that's gross," right? We have a new website, so check that out. And at the chapter hub, you can see what we're doing, but you can also click on all the other different groups and see what's going on across the US, and you can always join one of their meetings too.
Let's talk about passive house cooling strategies. Thank you both for the wonderful introductions and everything else. It's cool to see what all happens in our space these days. I really enjoy that. So today we're going to talk about keep your cool. Of course, Minnesota in the meanwhile has solved it itself by cooling down dramatically from like 2 weeks ago when it was just unbearable. But that's part of the challenge of this subject is that you can't control the weather and the climate very much so, you're going to have to respond, obviously. So let's see how we can do that in a passive house or in high performance building. I want to break this down into a couple of different sections here today. I want to talk about some of the big ticket items, things like massing, orientation, fenestration, even placing, location on a site. And what I call environmental shading, so things that happen that we don't necessarily control. I want to talk about common solutions that I think do not work. And then I want to show you, 3 items that you could unleash on a building that I think do work and give you a good result. So in that order. So let's get into it. The orientation, massing, fenestration, and environmental shading, the good, bad, and the ugly, so to speak. So let's start with some simple stuff that most of you have, probably encountered or can relate to. That's good in a passive solar design, and that would be trees, for instance. That's an environmental factor that we have on a lot of sites. And they, leaf out during certain times of the year, and then they drop their leaves at other times of the year. And so they can be a really powerful tool or environmental factor that comes into play, not necessarily one that we control, but it is helpful and can be used to your advantage. Of course, that requires some maintenance, maybe some pruning over time and things like that. But that's an example of, a factor that is existing on a site or that you can even create when you plant it, that is helpful. When we look at that as a factor, we again the bad of it is we don't only have so much control over it, right? So especially with the trees, but also other things like hills, mountains, tall buildings. So when we're given a site, there's all kinds of factors that can be beneficial, but can also be detrimental. And that's especially true in our cold climate zone, where buildings are very, very sensitive to solar heat gain. And so when we don't have it, we may actually be in a position where we can't get to certain passive house criteria. So that's an important thing to realize about your site, is that you don't pick it and you're dealt the cards you're dealt. And in some cases, and I have an example here where we ran into this is the urban infill project in Northeast Minneapolis. The right-hand side of that gray house that you see there is the south side, and there's an immediate neighboring building there that in the winter in particular steals a lot of the passive solar heat gain. And in response to that, we didn't even do a lot of windows there because there was no point. There was no view, no light, no nothing. So again, the good is we can try to harness these factors when they exist and make use of them, but we don't control them, so we have to live with what they give us. And in some cases, that can be detrimental to a certification or a certification at a certain level. And then, it can get worse. So when we talk about placement or massing of a building on a site, this building here, the Bright House 1, was an urban infill also for affordable housing developer, and they get dealt leftover properties. And in this particular instance, the first one that we built, the site was such that we didn't really have a solar facade at all. So what you're looking at is the back end of the house. That technically is the south facade on the left-hand side. On the right-hand side is what should have been the south facade, which now faces east. And in addition to that, there's a multifamily building on both of those sides, that further shades it. There's a big tree over the south facade. So again, this is the ugly then when all these things come together, right? Now, all of a sudden, the building is turned the wrong way. We got shade objects we don't control. So, that turns into a situation where, we may not be able to get to where we want to go. However, we can still do a really good job, making a building that is comfortable and works for people. It may just not, register on all the points of a passive house. Now, since we're talking about cooling today, to that end, of course, when there isn't much sunshine available or passive solar heat gain available, that on the flip side, that problem sort of goes away. You don't have to worry about overheating or anything like that so much anymore, because there's just not a lot of passive solar heat gain available. So I guess we can also turn that into a positive for part of the year. But since we're heating dominated, we're usually more fascinated with that. And the other aspect of it is when sun is available and in full force, right? We need to figure out how do we control that, because it can be really overpowering. And I think anybody here in our parts knows that. We have days when it's not particularly warm outside, but you can feel the sun's power really, burning, your skin or coming down on you. So, that power is wonderful. We want to harness it, but during certain times of the year, we don't. So, how can we do that and manage that and stay in control of that energy that's coming down? And the common solutions that I see in all types of buildings, not just passive house, of course, are two basically, and I don't think that they work very well. The first one that most designers jump to, I would consider that fixed shading. So that's anything from a particular window detail to like an eyebrow over a window or a trellis roof or some kind of an entry roof or something like that. And why does this not work? Well, first of all, it depends on what facade this is on, obviously, and the sun angles, as you can imagine, are wildly different, not just summer and winter, but also depending on the elevation of the home. And therein lies the rub, right? So the earth rotates, the sun angles change all the time, and that's independent of the interior conditions in the building. So we may want solar heating, we may not want it. So how do we look at that with fixed shading? That's a real challenge, right? And then we have weather in the mix. So we might find ourselves in a time of the year where, we're still getting solar heat gains into the building, but we don't actually need them anymore because it's already warm in there. So how do we make sense of that? Well, fixed shading struggles here because it can't adjust to these dynamic conditions. It's just there. It'll capture one sun angle at a certain moment in time, and that's all it can do. And so it cannot account for these seasonal differences or temperature fluctuations inside and out. And this is particularly well illustrated with that little graphic here when you go to the east or the west side of a building, again, in our parts here, because the sun angles tend to be very low on those sides. And so you can imagine if you have anything coming off of a building, a roof overhang, a trellis again, or a window eyebrow or something like that, if the sun is almost horizontal, these things don't give you anything. It could be an infinitely long shading element, but the horizontal sunshine will still fire through and the building has a chance of overheating. And that can be an issue, and particularly in the winter. I can tell you from my own experiences living in a passive house that, even on a day when it's -20 outside, if the sky is blue and the sun is shining, and I let it, I can get the house up to 80 degrees on passive solar heat gains. And at some point, you want to say enough. And that's where the fixed shading usually falls on its face. It's one of those mismatches where the passive solar heat gain coming in and the strategy that we're deploying are incompatible with what we want to achieve. So, and in addition to that, fixed shading does not give you anything else. There's no benefits in terms of glare control, brightness control, or privacy control necessarily. So again, it's sort of a one-trick pony and it works for like one situation in a vacuum. So not particularly useful. Useful for some things, but not dynamic, not adjustable. The other one that I see far too often is interior shading. So I think we have great salespeople that tell us that you can lower your AC load by putting interior shades or blinds or curtains up and block the sun in that way. And there's some truth in that, of course. If you put something between you or the interior and the exterior in that way, you're capturing some of the heat gain. But the crux of that approach is that modern glazing is made to retain heat, meaning, once the sun fires into a building, the glazing and its coatings are really made to lock that in and not let it escape anymore. That's the whole point of insulated glass units. So having a shading device on the interior is therefore wiped out because at that moment in time, the heat's already in the building. The only thing that you're able to cut off is maybe a direct heat gain from something hitting you as a person, a comfort issue, or something that's sitting near your window that you're blocking. But the heat's generally locked in, and that's where we struggle. And there's an additional sort of side effect of interior shading devices that is not to be overlooked. And that is that once you cover a window from the interior, you cut off any airflow to particularly the glass, but also the frame, of course. And so the window can't really bank on getting good air exchange with the interior of the building. Well, what does that mean? If you have high solar heat gain, what that means is you may get a lot of heating energy that sits between the glass and the shade on the interior. And actually, the European window manufacturers all advise against that because there's actually a chance that when there's too much heat stored there, the difference between the outside and inside gets too big that you could crack a pane of glass in that way. There's just too much tension created. And on the flip side, if in the winter you close drapes or curtains or use those insulated honeycomb type shades, then you're completely cutting off that airflow again, and you're actively helping cool that window pane in particular. And that means that there's a greater risk for condensation and liquid water falling out at the window, which then over time will damage the window. So the case in point here is that doesn't really work. It does give you, obviously privacy, some light control, glare control, those kinds of things. And it can certainly be used in combination with other things, but on its own, it doesn't solve the problem of cooling for solar heat gains that come in through the windows. All right, so then let's move to a solution that promises to do a little better. Exterior motorized shading, or dynamic shading, as I would call that. So we talked about earlier, the sun moves and is dynamic. So in my opinion, the sun control needs to be nimble as well. And we want to ideally capture the whole spectrum of that energy. So it's not just about the heat, but we want to manage the view, glare and reflections, get on top of brightness, work with privacy. And that's where, these exterior solutions really start to come into their own. For those of you who are immersed in the PHVP and the passive house realm, here's a little bit of numbers work that sort of underscores what I talked about earlier. So you can see that exterior shades provide factor 10 improvement over interior shades in terms of the managing the solar heat gain. And then really what you're left with here is really how do you control it at the end of the day? Because you can have them, but they could stay up. You can have them and they could stay down. And that means something. And in a perfect world, of course, they move around and they work in, sort of in conjunction with the exterior and interior conditions. And I'll talk about that a little bit more. But the impact is not to be overlooked. And again, in the perfect world, you can capture about 90% of solar heat gains with an exterior shade where, again, an interior device might give you a 10% reduction or something like that. So extremely powerful and a bunch of sort of side effects that you can utilize. And I want to point out that that's not just a passive house thing. This is something you can bring to any building. And I'm always amazed how little of this we see in North America, because a good chunk of the country has, a lot of solar insolation, particularly when compared to Europe, which is much more northern for the most part than we are. And you see these devices all over Europe. You don't see them here. So we try to get on top of that with mechanical solutions, I think, in conventional construction, i.e., air conditioning. But this would be a way to manage the light, the heat, the glare, and all of that in any type of building, really. In passive house, it's more critical, obviously. So let's dive into some of the components of it. There's first and foremost the motorized shade itself. So think of this as a supersized mini blind. They're typically made from aluminum. You can get them in different widths and heights, obviously. You can size them to fit your window. They typically run line voltage motors, so they really just need 120 volts. They can be track mounted or cable guided. So from a design perspective, you have a lot of flexibility where you want to set them in terms of your facade and how you want to integrate them. Also in terms of, are they hidden when they're up or are they shown? So the exterior are recessed mounting options. And there's a bunch of standard colors that you can order, so you can certainly find a good match to what you want to do with your building. The main considerations when picking a product like this are the looks, maybe the wind resistance, and the shading factor. Again, that depends a little bit on the installation, and the controls for it. I get a lot of questions from people about wind resistance and how to deal with that. So some basics around that subject. The most basic slats are basically just a half circle or half moon sort of shape. Those are not very good with wind resistance, and they typically have no rating. But you can buy an S or a Z shaped slat, and because of the way that they're bent and shaped, they're really stout, and those can be rated up to 50-mile-an-hour winds. After that, there's usually a protection mechanism where they go up so that they don't get obliterated by adverse weather conditions. In terms of the size of these slats, to put that in perspective, they're about 2.5 to 3 5/8 inch or so wide. Those are typical increments. There's a couple in between there, and you can cover up to 20 feet in height or about 215 square feet with one of these units. So that gives you a lot of flexibility. You can combine, windows that are subdivided into one unit, but you can also break that down. And based on how you do it, you get what we call the slat stack height. So when they're up, you get this packet that you have to park somewhere. So as a result of your selection of the slat, and of course the opening you're covering, you'll find out how tall of a package you have when it's up. And that's what you're dealing with then on the design side, whether to integrate it into a wall or hang it in a box outside of the wall. The shade box would be the element that captures the shade when it's up. You can buy pre-manufactured units. You can make your own. You can stick them in a wall. You can hang them outside, in front of a wall. There's all kinds of choices, and they mean something for design and function and maintenance and all of that. But there's usually a solution that fits everybody. So there is a lot of flexibility in how you integrate a system like that into your building. So I think that's a huge plus. And obviously then they work in new construction and retrofit. So since they can be bolted onto a building, this doesn't have to be designed out of the gate to be fully integrated. You can literally, as long as you can get power to a location, you can still mount them to the exterior and cover windows and start managing them. And the controls, by the way, can be hardwired or wireless. That gives you even more flexibility in how you want to control them. When you're building new, I would recommend that you do some kind of an integrated design. Here's a detail that I came up with some years ago for a project, and that just shows how the shade box is actually part of the inside of a wall, and the shade box itself is built from an insulating material in this particular detail here, so that we don't have a massive thermal bridge at the window head. And so in the sort of best possible version of this, you integrate it in this way. You have no negative side effects for the building, and the shades are there when you need them and out of the way when you don't.
There's a question for you.
Oh yeah, go ahead.
Hey, Tim, it's Scott.
Hey.
I'm just curious, like, obviously you've spec'd these and installed them. Why don't we see more of, I associate the solution within, Europe or, yeah, pretty much Europe. Why don't we see more of them here? And like, is it just a cultural thing, or we don't know about it, or like, why?
It's a great question, Scott. I wish I knew the answer to that. I think it's probably that not enough people know about it, even though you can see them obviously in other cultures used very heavily. And then I think we just have a dominance of solving any kind of temperature and comfort issue with mechanical solutions, right? So when you have a comfort or a thermal issue in the United States, who's the first person that gets called? It's the HVAC contractor. It is not the window or building envelope person. And I think that's that. And then I will also say that the companies that sell this product, even though they are global companies and you can buy this just about anywhere, including the US, they don't have a very significant footprint here. They're not very visible. They can be hard to find. And so I think that in sequence or in series is the reason why you don't see it more. They're not particularly expensive. I will tell you that. I have in my career installed many indoor window treatments in maybe higher end homes, often motorized, that were integrated into the wall. And those can be more expensive than these units here. So I think they probably compare very well with an interior motorized shade solution. There's certainly a little more than your whatever store-bought mini blind or something like that. But given what you get out of them for the performance benefit to the building, I think they're fairly priced. Yeah.
Thank you.
Yep. Here's a quick picture of what this integrated shade box might look like. Again, this is just the physical manifestation of the detail that you saw earlier. So it's simply integrated into the exterior wall cavity. You can see there's an outlet mounted with the power pigtail sticking out for later hookup. And then just a quick sequence. For those of you who have visited my house, you've seen this. So I just have, I don't know about video in these presentations, so I'm going to use slides here. So you can see, you know, how they do their dance. Obviously, they go up and down, and then they articulate. And that's really the key benefit here. Again, they can do this all day long. They can choose the proper angle to maximize the view and the brightness in the house, but cut the solar heat gain when it is not desired. And that's really the main selling point, I think, of these dynamic solutions. And the importance of it is illustrated here. So I did a case study about the house where we took 2023 and we ran that against the PHPP. You can find that on Passipedia if you're curious. And also, I think we'll present that at the next international conference. But be that as it may, you can see if my home would not have exterior shading, the cooling load would just be absolutely outrageous. That's that bar on the right, and that gives you an idea of the importance. Again, goes back to this premise of power is nothing without control. So the benefit of being able to heat the house passively in the dead of winter comes at the expense of I got to manage this at other times of the year when we don't want that heat gain anymore. And so I just thought this was a good visualization here where you can see a massive footprint that would occupy given how much glass I put in the house. So the importance of this dynamic shading is really great and has to be recognized. The components that you need some kind of a controller, obviously. You know, in the most simple case, you can literally connect them to a switch. I have a couple of clients who do that. They didn't want any kind of centralized control system. So they literally just walk up to a window and they hold the switch up and hold the switch down, and they can do that all day long. I don't recommend that. It's just something that's difficult to manage. And more often than not, somebody like that will probably either keep it open or closed, which defeats the purpose. So one way to do it, or another way to do it, would be what we call the actuator, which is just a little plug that goes on each shade that you can then talk to and start to automate and maybe remote control the shade. And here's just one visual example of a product that does that. Some of the manufacturers have that built into their motors, so that already comes set up in that way. But here's just one solution of how to connect to the unit, and this can be wireless or wired. And then if you think that through, you need some kind of a bug or some kind of a hub that takes these signals or distributes them. So here I'm holding in my hand a home automation server. These days, those things are barely bigger than a credit card. And so that machine can be programmed to run a program based on sensors inside the house, a weather station outside the house, and I can set some parameters and say I want these temperatures and these conditions, and I want to favor, let's say, daylight over heat gain or something like that. And it can then balance and write these shades up and down. Actually, as we were speaking, you probably didn't see that, but the shade to my left actually just went up because the sun is now on the south side of my house, and the east side no longer needs any shading. This can also be simple timer controls. So in my home, for instance, we have it set where at a certain time at night, they come down every day. So people don't have to manually do that. The house basically just shuts down. And in the mornings, we leave it manual because people get up at different time of day, so they can push a button and it can go up. So that's the advantage of starting to automate a system like that.
Have you
Um,
seen,
yeah.
and maybe this is what you're about to say, but is there
Yeah.
one that closes up in case of fire or anything else that?
Sure. It's actually the opposite, Susie. So if you had a fire inside the home, they typically, the automated systems will open up. And the reason being, you want to get out and you want first responders to be able to get in. So if you have your smoke alarms connected to the system, they will cause the shades to go up.
And for wildfire,
Okay, that's different. Yeah, you could for a wildfire, you could obviously shutter them if there were a benefit to that. So that's not a problem.
right.
I was
But you
thinking
haven't
about the
seen an
interior.
automated, you haven't seen it like a setting yet that will just do it based on information, local information.
It would be possible if that information is available digitally, either on some kind of an alert system, and you can pick it up with the home automation system these days. You could read that and then automatically shutter the home if that's what you want.
Mhm.
And to that point, so other things you can do are wind protection, frost protection. This is of the shading devices. So these are not your Florida hurricane shutters. They are meant for something different. And so they're not here to protect the windows from storms. And as I mentioned earlier, they top out at about 50-mile-an-hour wind. So if you get more than that, they should retract so that the shades don't get obliterated. And typically the way that's solved is with a little weather station on the roof somewhere that sends a signal and says, okay, winds are super high now, shades go up. And similarly, you can do frost protection. When you live in parts of the country where you're prone to, let's say, freezing rain or something like that, and there's a chance that you'll get a ton of accumulation of that on the slats themselves that would weigh them down or even cake them together where they can't open anymore, you can program those parameters and then send the shades up so that they're not subject to, again, taking any kind of physical damage from added weight or frost or wanting to move and not being able to. In reality, I rarely see in a situation like that in Minnesota, but I do have a frost protection program on mine. And every once in a while, that does get triggered in a freezing rain or something like that, and I see them go up. And the other benefit is, of course, with the combination of maybe sensors in the house, weather station on the roof, you get this minute accurate shading or the opening, or I should have put our closing of shades. So they literally, they can dance around all day long and do exactly what they need to do to give you the right sort of protection for the building interior and keep that at a comfortable conditions. Maybe on that note, what I'll add too is that lost my train of thought. I'll come back to that. Sorry. One other question I always get from people is, well, how do you maintain them? And I've actually been through that with the manufacturer. So maybe in other order than I wrote it there, but the individual parts can be fairly easily, I should say, exchanged on these units. They're actually pretty resilient, more resilient than you think. And every part on there can be ordered individually and can be exchanged. For some of these repairs, you would have to take the shade back down, fix it on a bench, and stick it back up. But they're not particularly complicated devices. Again, if you know a mini blind, they're basically the same, except in the head, they have a motor instead of you pulling on a cord. And so there's very few moving parts or parts to it in general. You have pull cords in there, and then another cord that adjusts the slat angle. You have the slats, and then at the top, there is a frame that holds the motor and the spindle, and that's just about it. So they're very friendly in terms of maintenance and or repair or complete replacement. If that should ever be necessary, you can reorder a unit the same size and just plug it back in. And maintenance is generally minimal. Having lived with them for many years, I can tell you, mostly for visual reasons, you want to clean them every once in a while. And here's a brush that I bought for myself that I hook up to a garden hose, and basically it squirts water and I run it through the slats. And, if I feel up to it, I might do this twice a year. If I don't feel up to it, I might do it once every other year. But, that's an easy way to maintain them. And obviously, if you had any obstructions or something in the track or something that you can see, you want to get rid of that. But that's all for maintenance. So it's fairly light on the maintenance. So let's expand on that. That's not the only way that we can do cooling, obviously. So we've now managed the windows. There's still other things that we can do and maybe should do. And I want to continue on this track of what I would call passive cooling first. Obviously, that only works when it's available. So the first thing for those of us who are in the passive house realm that we can activate here is our balanced heat recovery ventilation system. Most of those systems have an automatic bypass. And what that means is that when the conditions are such that we can get some meaningful night cooling or something like that, it just opens up the hatch. It forgoes the heat exchanger in the box and just flushes the house with cool air. I can actually sense that in my own home sometimes because the thing goes into overdrive too. It'll actively, in that case, actively try to flush more cold air into the building. So the bypass when you spec a ventilator would be a meaningful way to get more cooling into the building. And the other part is the ground source preheater, which in the cooling months turns into pre-cooling. So if you have a ventilation system that, and here's an example of that has a ground source heat exchanger connected to it, that's the picture on the left, you can extract the coolness of the ground year round. And in the winter, that'll be warmer than ambient air and it'll keep the machine frost free. In the summer, it'll do the opposite. It'll cool the incoming air and dehumidify it to some extent. That's why there's a drain on that gray box. So earth loop or earth tube, the earth tube is the same thing, except you're bringing the air in underground in a passive heat exchanger type fashion. Both of those would be great cooling strategies that you can unleash on certainly a passive house or any other building, short of an active system. Windows, of course, you can use those. So when the conditions are favorable, I would say Minnesota is a difficult climate for that. Most times of the year here, we're too hot, too humid, too dry, too cold. You can literally count the hours per year where it's the right condition for meaningful night cooling. But obviously, if that's available, you could do that. And then from there, we transition, and I know I'm running a little short on time. I apologize here, but I will wrap this up. We're transitioning into active cooling. We're back to what I said earlier, called the HVAC technician. We still have all of that, of course. Hopefully, this day and age with some kind of a heat pump system, either a ground source or air source. Hopefully, you're all familiar with that. You can have air handlers, you can have cassette type units, and that's how we can take it the rest of the way to cool the building. And then, the sort of 800-pound gorilla in the room is, of course, the humidity, especially in buildings that have a tiny little cooling load left. You might have a dehumidification load that you want to get on top of. And the only way to do that then is, beyond the earth tube, earth loop, what we talked about would be with an active dehumidifier. So that would be to top it off. But I would say these are the equalizer and these are the last thing that you go to, not the first thing, which is common practice now. And as an added bonus, I can also throw this in the mix, the heat pump water heater. For those of you who have seen these units, is essentially an electric water heater with an air conditioner, a hat plugged on top of it. And that unit will take room air and turn it into a hot water. And by virtue of that, it'll cool and dehumidify the room air. So this effectively is an indoor air conditioner. And that does contribute particularly to a passive house interior. I think it was on the slide where I showed the graph of the energy used in my home for cooling. And it does contribute, with some, portion to the overall cooling load. Of course, in the winter, I have to heat against that because it'll do the same thing year round. But you can look at this in the summer months as essentially free warm water because it takes that heat that you don't want in the building and gives you warm water in return. I think the resources were already shown. So with that, I thank you. I'm happy to take a few more questions if we have time.